Right, hello. My name is Carlos. I'm going to show up this very simple application. It's essentially a GPT wrapper. It's for my database. No, it's not database. I'm sorry. It's my cloud project course at IsCool, and this is the project. It's essentially I would separate it into three parts. It's a front end deployment. It's a back end deployment, and it's also a database deployment. And we're going to go over the architecture. We're going to go over how this is working right now. We're also going to go over how the application works, what are the main things it can do. So first off, let's start with some front end part, right? So this is our Vercel deployment, as you can see right up top. And what this is that it's an educational GPT wrapper. So you can ask it anything that you'd like about education, whether that be, historical questions, computer science questions, whatever you'd like. And it should provide you a summary as well as details of the question that you asked. So let's start off with some very simple stuff. Who colonized Brazil? I actually did this question right here in this chat, as you can see. So let's do something new here, right? Let's put in, who is the president of China? China hasn't changed presidents in a while, so this should work with GPT's knowledge cutoff. Alright, so Xi Jinping is the current president of China. That is correct. You can see that it has the little chat name here. It's very inspired by ChatGPT. Let's ask it something else. How did China how did China industrialize? This is an interesting question. Yep, there it is. China industrialized using economic reforms. That seems legit. So there we go. This is our app. It has support to JWT authentication. Obviously, you can create new users. So let's just do this for fun. I'm gonna put in Tinoku, which is the teacher for this course. Tinoku is gonna have this email called tinoku@gmail.com. This is the username. This is the email. Tinoku Prof is the user. The password is going to be very simple so that I don't forget it, because I always forget testing passwords and then I have to make a new account. So password 123. He is a teacher he is a computer science teacher at Cesar. I think this will be too many characters, so I'm just gonna put it computer science teacher. Alright, so there we go. This should work. Let's create the account. Yep. Tinoku@gmail.com. Password 123. Let me just make sure that this is. Oh, there we go. Okay, so here we have Tinoku's account. Like I said, we can just ask him anything. So, I don't know. Who invented the first automobile? This will be interesting. Carl Benz is the inventor of the first automobile. Cool. Alright, now that we've gone over the main implementation, which is the project that has actually been deployed, let's have a look at its components. So we're going to start with the backend. So what we have here for the backend is a very simple model view controller type of deal, and nothing really too complicated, right? And it's built with C#, which is my favorite language as of this moment. So what we have here is, pretty standard stuff. We have exceptions, we have models, we have services, and we have two services. User service, which we use for, registering, and chat service, which we use for, talking to GPT. We have a direct injection of Entity Framework Core. Since this is such a small project, I didn't really think of a repository layer as a necessary abstraction, but you know, I think that in this case, Entity Framework Core already gets the work done fairly okay. You can see here that it's very streamlined. You can have a look at the controllers, which is where we actually route things. We can have a look at the middlewares for authentication, which is where we render out the user DTO based on the JWT token. And yes, we do work with JWT tokens in this application for auth. It's about the application is essentially that it's very simple. So it's a very simple application. And what we're building in here with is Docker. So here is the Docker file for the project. Essentially what we do is that we go to the SRC directory, we copy all the files to SRC, we build the project, we publish the project, we copy app settings JSON into the project, and then finally we expose its binary as IsCool DLL. Now this app settings JSON part may have been a bit of a stupid idea, to be honest, because I didn't think of leaving the variables at the environment variables part of Azure, and I didn't know how it integrated with the the builder configuration thing with .NET. So I preferred to build the app settings JSON in the YAML file, which wasn't the best solution looking at it now, because essentially what it did is that it didn't quite build the correct file many times, especially considering that variables may have weird characters such as this or that or whatever, right? Either way, things are working, which is more than enough for me. So right here we have, at least for this project. So right here we have the YAML file. The YAML file, we're only publishing things when they're in main. There are three branches, which is main, which is production. We have dev, which is development, and we have staging, which is the QA environment, right? And what we have here is that we have some steps. So first of all, we start the Azure Container Apps and Container Registry. We go over to unit tests. We check out to the code. We go over to unit tests, and we make sure that the tests are running correctly. I'll get over to tests in a second. We create the apps. We create the app settings JSON file. We validate it with GQ. We log into Azure. We build. We push. We deploy. It's very standard stuff. Let's go over to the test part. So the test part is localized in another solution. It's called IsCool.tests, right? We have our own DB context, which is in memory, and then we have the unit service tests, which are right here. All right. I think that is the backend part. We're using mock and XUnit for tests, by the way. Alright, so now that we've gone over the backend, let's have a look at the front end. For the front end, I'm using TypeScript and I'm using React. I find them to be, personally, I'm not that much of a fan of TypeScript, but it is the solution for, a lot of the errors that JavaScript has, and it's essentially the go-to form of creating, especially front-end development. So right here we have a very basic, very straightforward, standard components and pages. It's all built with React and Vite, and it's deployed with Vercel. It's quite simple, not much to talk about here. Vercel already takes care about all the pipeline, all the pushing part, so no need to think about this in this front-end project. The image is being pulled and the DL is being exposed to a port, and that port is being accessible in a URL, so it's the part that actually makes the magic happen. And then the database, it's quite obvious. We're working with Postgres, which is my favorite database. I think it's most people's favorite database. It's it's in a flexible server. All three of them are deployed in the same zona de disponibilidade, which would be Canada Central. Let me just have a look here. Yeah, Canada Central. And this assures that we don't get too much connection overhead in between them. If you look at the IsCool environment right here, which is our application, you can see how it's deployed correctly. So why Azure exactly? Well, Azure is very integrated with the Microsoft environment. If I'm not mistaken, most of its code is actually written in C#, which is the language that I used for the project. And if I'm not mistaken, you can actually deploy app service applications by the Visual Studio IDE directly without even needing to leave the the code. So essentially, it's very integrated with the Microsoft stack. It's very used nowadays, and I find it to be a very competitive option. It's very straightforward. I just wish this Copilot thing was better. But yeah. We've gone over how Azure is set up. Let's have a look at how Vercel is set up. So first off, why Vercel? To me, Vercel is the basic way of deploying a front end. It's very simple. It only bills you if you have lots of traffic to your API or to your project. To me, it is the best serverless, especially for front-end applications. It's not as robust as other, very easy serverless platforms as a service, like Railway, for example. But it is made for React. It's made for and it essentially allows you to put applications out there in a click of a button, which to me is insane. So I very much enjoyed using Vercel to do this. I've used it many other ways. You can see it here. I have other deployments. Very simple, gets the job done, and that's it. Finally, let's get to how things are set up here in our GitHub. As you can see, we have GitHub Actions, and it's working fine. This was the last job. You can see that it finished all the steps gracefully. There we go. And we do have the three branches. As I mentioned before, we have dev, we have staging, and we have main. A reminder that dev goes to staging and staging goes to main, which is essentially how most companies use their workflow. Here's the README in case you want to know more details. And let's go over to the front end now. Let me have a look here. It's a private repository, but I might as well make it public. There we go. As you can see here, we also have CI/CD configured, but Vercel takes care of all of this. So, yeah. Anyways, this project was a huge opportunity for me to learn how to get software out there, how to handle containers on the internet.